As we already said in our learning objective, we will be using patterns to help us factor trinomials. There are three important patterns. You have heard of them before in Algebra 1, and they're important to know and remember and essentially memorize because, again, that will make our factoring effort way easier. The first and most important one of them is the difference of perfect squares. The way it goes as a formula is a squared minus b squared, that's what you see, difference of perfect squares, right, is equal to, and when you see it in factored form, you get a plus b times a minus b. Let's look at an example here. 4x squared minus 9. If we look at this, we realize, wait a minute, 4x squared, that is a perfect square. It's the perfect square of 2x. And 9 is the perfect square of 3. So we can say, so a is equal to 2x and b is equal to 3. And since the factored form of the difference of perfect square is a plus b times a minus b, which essentially would be, if we look at it in unfactored form first, we get 2x squared minus 3 squared, and then we break it down, and in factored form, it'll look like this. 2x minus 3 times 2x plus 3. And you're done, and that was way faster than having to go through an entire factoring process, which is also a little complicated since we don't have a middle term here. So we would have to use a trick. This is way easier. Let's look at the perfect square trinomial, and we actually have two of them. One is with addition, one is with subtraction. A squared plus 2ab plus b squared. If that's what we see, then we know that the factored form of that is going to be just a plus b squared. So for example, x squared plus 6x plus 9. If we realize that the square root of 9 is 3, and 3 is also half of 6, we can already go ahead and write this down, and essentially what we get is x plus 3 squared. Because what happened is a was equal to x, and b equal to 3. With a little bit of practice, you will get the hang of it, and you will just look at the numbers. You will see, oh yeah, I see a perfect square in the back. Let me just check the coefficient of the middle term, and then I should be in good shape. And as I said, we do have a perfect square trinomial also with subtraction. Now let's look at this example. X squared minus 10x plus 25. You will say 25 is the perfect square of 5, and 5 goes into 10 two times. That's all we need to know. And since the middle term has a negative sign, it's the perfect square trinomial with subtraction, where a was equal to x and b was equal to 5. All right, so let's move on. You have seen this. An equation of the form ax squared plus bx plus c is equal to 0 is what we call a quadratic equation. And when we have it set equal to 0, the values that we find for x that make this equation become true, that satisfy this quadratic equation, have 4 different names. You know those 4 names. Let's just remember them. Zeros is what we call them, because y is 0. We call them the solutions to our equation. We call them the x-intercepts if we think about our parabola and if we think about where it crosses the x-axis. And we also call them roots. Now here's an important thing that we know and that we know now that we also have learned about the imaginary numbers. A quadratic equation always has two solutions. It always has two solutions. Now those two solutions could be two different numbers. It could be a double solution, and it could even be two complex solutions. But it always has two solutions. Now to find those solutions, we will use a property that we have talked about before, the zero product property. The zero product property, if you remember it from Algebra 1, goes like this. If A times B is equal to 0, in other words, a product of two factors A and B is 0, then we know that one of them, at least one of them, either A or B, have to be 0. Otherwise, we wouldn't get a product that's 0 if not at least A was 0 or B was 0, and possibly even both. And we can use this to find the solutions after we have factored and looking at our factored form of our trinomial, which is our quadratic equation. If we know that x plus 2 times 3x minus 1 has to be equal to 0, then we know that either x plus 2 is equal to 0 or 3x minus 1 is equal to 0. And in the first case, if x plus 2 is equal to 0, that tells us x has to be equal to negative 2. And in the second case, we just go ahead and solve the equation, adding 1 on both sides. We get 3x is equal to 1, divide by 3, and x is equal to 1/3. X is equal to negative 2 and x is equal to 1/3 are then our two solutions to this quadratic equation, which incidentally is in intercept form, right? Remember when we talked about graphing? This is intercept form. This next equation we still have to factor real quick ourselves. Target sum is negative 5. Target product is negative 36. This gives us the numbers 4 and negative 9. In other words, our factored form is x plus 4 and x minus 9. So if x plus 4 has to be equal to 0, then x has to be equal to negative 4. And if x minus 9 has to be equal to 0, then x has to be equal to positive 9. And those are our two solutions. And yes, please note that the solution always has the opposite sign of the number that you see in the parentheses of a factored form. Very important to remember that the signs switch. And here's why. The x plus 4 is equal to 0. So which number makes that become true? The opposite of 4, which is negative 4. And let's do our last example together real quick. 5x squared minus 45. And yes, you paid attention and you already saw that there's a greatest common factor. The greatest common factor is 5, which leaves us with x squared minus 9 is equal to 0. Oh, and we see now in parentheses we have a difference of perfect squares. We have x squared minus 3 squared in parentheses. In other words, we can use our pattern that we just learned to tell us that the factored form is 5 times x minus 3 times x plus 3. And now let's go ahead and find our solutions. X minus 3 is equal to 0, therefore x is equal to 3. And x plus 3 is equal to 0, then x has to be Negative 3. Well done, you guys. This is it for the first part of factoring, and I will see you in class.